If you haven't downloaded them, it's still okay. You should be able to follow along. As I said, my name is Lawrence. I do security things nowadays. I mostly do detection, prevention type of activities, especially from a security operations center perspective. I'll say that is my domain, but of late I find myself everywhere. So I'm what you'll call, there's this common term people use. I'm what you'll call a jack of maybe all trade, or a jack of most trades, which is ideally better than someone who only knows one skill, but on a very lighter note. So with that, we should be able to proceed. I'm just going to share my screen just to start this off. Now, I'm not going to be using any slides for this particular session. I would like to make it as interactive as possible. So at any point, if you want me to maybe slow down, maybe share a specific activity in details, please let me know. So at the moment, I'm trying to figure out how to share my VirtualBox window. So just give me a minute as I figure that out. I initially thought I'd figured it out. Apparently, I had not done a good job of figuring it out. So just give me a tiny minute as I figure this out. I should be able to proceed in a second.
And guys, if as he's working on his system, if you have any questions, you can just ask them on the side chat, so that he can be able to demonstrate solutions to or responses to your questions in as early as possible.
Okay, we should be able to proceed now. Michael, you can let me know once my screen is visible.
It is visible now.
Awesome.
It has started presenting.
Awesome. So interesting thing is when I was preparing for this, guys in the organization committee told me that the demo gods are going to be with me today. Maybe you have prophets amongst us. So when we talk of virtualization, when we talk of home labs, setting up home labs, why do we talk of these, and what's the importance of these? Now, if you hear some notifications, kindly do not mind them. Those are more guys joining the call. So virtual labs or virtualization basically allows you, well, without going into a lot of technicalities, it allows you to run, in most cases, multiple operating system on a single system. So this single system in most cases will be referred to as your host. Then on top of your host, you can virtualize a Windows machine, a Windows server, basically any operating system you can think of. Now, when you talk of home labs, when you start being deliberate with your virtualization, so for instance, let's say you want to learn about Windows administration, similar to what Labu took us through the other day, yesterday. So when you say, okay, I want to create an active domain machine, this active domain machine, I want to connect it to to maybe other workstation and have them join the Active Directory. So when your approach is more structured that way, essentially what you're doing is creating home labs. So you can create a home lab to either set up AD, you can create a home lab that has multiple machines, a single machine. The main point is just to create machines to help you practice, test out things, and improve your skill set. We have multiple tools that you can use for virtualization. One of my favorite tool is VirtualBox. A reason for this is, well, it's free. Actually, I think because it's free is one of the main reason I use VirtualBox. So the interface you're seeing right now is the VirtualBox interface. From my interface, you can see multiple machines or multiple tabs. So we have this first tab here called AD Lab. So what this is, it's what VirtualBox calls groups. So groups basically allows you to organize your labs, organize your virtual machine. So if I was to drill down into my AD Lab, you'll see that I have a couple of machines. So if I didn't have all of this grouped, then I'll have a lot of machines on my left panel, in which, for me, I usually don't like when everything is cluttered, too much information. So moving away from that, if I come to my Git lab, you can also see I have also other labs right here. So the moment I collapse this, I can only focus on the labs I'm interested in, or the virtual machines I'm interested in. Now, if it's your first time with VirtualBox, in most cases, this interface here will be empty because it won't have any machine. Now, to start us off, I'm going to take us through my approach, the approach methodology I use when I'm creating labs. Then we are going to look at some curveballs, some of those areas that we typically I didn't focus on. So we are going to look at the networking aspect of labs, how to play around with the system resources, how to enable sharing of content of files from your host to the VirtualBox, and just have some discussion in regards to why that at times is desired and why that is not desired. So to start us off, what approaches can you use when you're creating labs? So for me, the approach I typically use is just to have a logical mental picture of the kind of labs or the kind of deployment or the kind of architecture I want to achieve. So for instance, let's say we are going to have an AD lab. So now, given that you have an AD lab, I'm trying to see if there is a way I can share. I should be able to share my paint. So let's play with paint a bit and just see how you can use a structured approach when you're creating your virtual labs. So reason why I say use your structured approach, it can help you quickly identify technical areas that you need to pay attention to. So those technical areas are typically the networking aspect of your lab and how you want those machines to communicate. So if you are to use the Active Directory lab example, so the first thing is just to have a mental picture of how you want your network to look like. So let me go to shapes here. So I'll say maybe this is my server 1, server 2. So let me pick the pencil. So I say this is my server 1, server 2. I want these two guys to communicate with each other, and maybe I might want these two servers to also have internet access, or I might want them, maybe only server A, to have internet access. So I just structure that also down. So I call this net. Forgive my drawing. Then once I'm here, maybe I'll say maybe these are the IPs I want these two servers to have. So something along those lines. Now the importance of this is with this, I know that I'm definitely going to create three servers. A and B have to communicate, so that I have to ensure I have network. I configure some network aspect of this. Then I have to ensure A can access internet. So that just helps me know the kind of effort, the kind of technology I'm probably going to use for that particular lab. Now for our exercise, I will be using CentOS, which is a variant of Linux. So I already have a Cent already here deployed, but we are just going to start from scratch. Now, if you already have groups, and I will show us how to create groups. If you already have groups, this interface might change. You might be wondering, so how do I create a machine and all that? If you have group, so for instance, I have AD lab. If I want to add a node into my AD lab, I'll just click on group and new machine. Now, for most of us, this is the interface you will be able to see. So you will see your file, you will see your machine, you will see the snapshot. So what you're going to do next is let us create our first node. So let us create our first server. So let me just mute a few notifications here. So we are going to create our first server. Now these servers will be two servers, basically two CentOS servers for us to be able to see the networking aspect of things. Now, as much as I'm using Cent, the approach is similar for Windows Server, for an Ubuntu server, and all that. Now, you might be wondering why I'm using CentOS, as much as it is discontinued. I will come back to that in a bit. So to create your first virtualized machine, you want to click on machine, then click on new. Now, when you click on new, next thing you want to do is give your machine a name. So in my case, I'll call this server A. The machine folder is typically default. If you have a different place you want to save your virtual machine, you can select it right here and give it any folder. Then by default, it will pick a Microsoft Windows. In our case, you're going to use a Cent. So I can click on this type, scroll down, pick the flavor I want. In my case, it's Linux. Then specify which variant of Linux I'm interested in. So Cent and Red Hat go hand in hand. In most cases, personally, if I'm using Cent, I usually go for other Linux. Now you might be wondering, what's the importance of all these? Now, if depending on the type you pick, VirtualBox will try to automate some baselines for you. So it will give you recommended RAM, recommended hard disk, and all that. So for example, if I was to choose still Linux and I specify Ubuntu 16, you see, now my RAM has increased to 1024. So that's just something you want to be aware of. Same thing will happen also on Windows. So if you're not sure of the resources you want to use, just go with the default. And this is also where that aspect of having a logical mind map of what you want to achieve comes in. Because you might know that, okay, for this server, if it's a Windows server, I probably need at least 20 GB of hard disk, maybe at least 2 GB of RAM. But in our case, this should be okay. So I leave the RAM as it is, 512. I'm not going to change any of the defaults here, especially when it comes to hard disk. Maybe in another session, we might go into a deep dive in regards to using these hard disk features. But for most cases, specifying the RAM, the name of the server should be okay. Now, something to note here, you want to have the name of your server with a leading name. It will help you easily pick up which server actually does what. So I'll say CentOS server 1. Now, the more servers you have, one of the issues I usually run into is trying to figure out now, this server A, what was it meant to do? So for me, most of the time, I actually say CentOS server, maybe with Apache or something, just to make it easy for me to recall what that server actually does or what it's running. Once you're done with that, click on create. Then on create, you will be told where your disk is, your virtual disk. In most cases, it will be basically in the same folder where your virtual machine is actually hosted. So in my case, the folder was VirtualBox. Now VirtualBox goes ahead and creates a parent folder that contains the name of your virtual machine, and then everything in your virtual machine will actually be stored into that particular folder. Now, it's important to know this because at times, if you want to basically use that particular virtual machine you have created, you just go into that particular folder and copy everything there. Copy it, move it to your hard disk, flash drive, whatever you have, take it to a different machine, and that from that machine you will be able to continue with your work. Now the file size has been predefined for us, 32 GB. I'm going to reduce this to around 15 GB. Now, something to point out here is for most Linux systems or servers you'll be creating, I've seen this happen a lot of time. If you give it less storage, less size, when you actually try to boot that VM later on, you will get a kernel panic error. In most cases, the info you get might help you troubleshoot what is wrong. at times it won't be very useful, especially if you're starting off. So my recommendation is, if you're creating a server, at least give it 15 GB of RAM. You can still play with a 8 GB, 10 GB, but just be aware that if the storage is not enough, if the hard disk is not enough, you'll probably get a kernel panic, and you'll have to, in most cases, either extend the disk or just start afresh. So it's okay to leave the default for now. So once this is done, we just click on create. Now, the moment you click on create, then I selected a Windows machine. That will explain why I had the weird storage. But the moment you click on create, you have everything that you needed already set up for you. Now, given that I did an error, I can still, well, the easiest approach, technically this will still work. If I boot it with an Ubuntu, a Linux image, or an ISO, it will work. But just to ensure you're doing this the correct way, I'll right click on this and just remove it. Now, when you're removing your virtual machine, you can either remove it only. So when you remove only, what you're doing is you're basically removing it from this left interface right here. However, that disk it created, that particular folder it created, will still exist. So in my case, I can go ahead and just delete all files. Now, reason why you want to delete all files is that storage you allocated will still be consumed. So if you want to reclaim space, delete everything. Just don't remove only. You want to also delete the associated files. So I'll quickly just create the server again. So I say Linux, other 64-bit. Depending on the Linux you have, you can either choose 32 or 64-bit. I call this CentOS. So the RAM is okay. I'm leaving everything else default. Now, something to note here is I chose CentOS and my version changed from a Linux to Red Hat. So VirtualBox will also try to help you do things efficiently. But at the end of the day, it's up to you to figure out what you want. So I have 8 GB. I will increase it to 25. Sorry, to 15. Then click on create. Now, once you have clicked on create, we haven't installed the OS yet. So it's just a blank dummy box. So the next step you want to do is click on start. Now, before I click on start, let's just take a moment and see how the compute side of this VM is. So let's see, maybe you want to change the RAM, you want to tweak a few things. You also want to have a look at the network. Recall that one of these servers is meant to have internet access. Then one of the two servers are also meant to have a network connectivity between each other. So I will go to the node I created. I click on settings. Then on settings, I can go ahead and change the name. I can click on advanced. I change my snapshot folder. In most cases, if you're just starting out, leave this as default. Now I can change my clipboard and drag and drop. So what shared clipboard and drag and drop basically mean is shared clipboard allows you to copy paste content between the virtual machine and your host. In most cases, that is disabled. In most cases, it can be a nuisance. It can be a nuisance because if I go to my browser, I maybe I'm on my browser, I go to GitHub, I copy a link, I want to paste that link on my virtual machine. I might not be able to do that if my virtual machine and the host are not sharing a clipboard. So you want to be aware of that. Now, at times this is discouraged because some malware or viruses can use this to escape. Then also, additionally, depending on what you are working on, you might not want to have any connectivity or any association between your host and virtual host. Maybe if you're working on malware and all that. Now, drag and drop basically means that you can drag files, folders from your host to your virtual machine and vice versa. Depending on what you're doing, it might be a desired thing or not desired. If you're working with anything malware, any viruses, I always recommend to disable shared clipboard and drag and drop. So in this case, I'm going to enable shared clipboard. Now, when you enable shared clipboard, you get multiple options. You have host to guest. Now, with host to guest basically means that if I copy anything from my host, I will be able to paste it to the virtual machine. From guest to host means that I can copy things from my host, my virtual machine, in this case the guest, and paste it to my host. Bidirectional goes both ways. I can copy and paste content to my guest, copy paste content from my guest to my host. Now, when I'm working with servers, I typically use bidirectional. When I'm working with Linux, I usually don't bother with a drag and drop. Then we have description. You can enter any description to help you describe this particular machine. You can encrypt your disk depending on what you're working on. So if you're using virtual machine, maybe for software development, to do some confidential work, yeah, you can go ahead and encrypt that particular disk. Now, reason why you want to encrypt that disk is recall the folder where your machine is. So if I gain access into your system, I can basically go to the VirtualBox folder and copy all your VirtualBox machine. So if those machines were not encrypted, if they were using weak password and you had confidential data there, then it becomes easy for me to access. So once that is done, you can go to system. With system, you can reconfigure the memory, reconfigure the processor, and just tweak a few things here and there. Importantly, you can also change the boot order and also I believe, okay, attaching the USBs on a different aspect. But most importantly, for system, I usually focus on just either increasing or reducing the RAM. Now, a trick that I typically use is that when I start creating my server, I will increase the RAM. So maybe from 1 GB to maybe 4 GB. Then once that server is up and running, then I basically take it back to 1 GB of RAM or something of that sort. Same thing with the processor. So when I'm just starting the deployment, I typically increase my processor and CPUs so that I just nifanye vitu teke. I do things very fast. Then we have display. In most cases, I don't bother with display. Storage allows you to, one, add another hard disk, and most importantly, it allows you to select your ISO file. So the ISO file is the file that you want to use to boot your virtual machine. Now, if you have formatted your machine, you'll either plug in a USB drive that has the operating system, or plug in a USB drive, not USB drive, a DVD drive if you are working with maybe if the operating system is on a drive. Then we have audio, just as the name states. Then we have a network. Now network is where I want to spend some bit of time. Network determines how your host and virtual machines communicate. By default, you'll have NAT. Without going into the technical details of it, NAT basically, in most cases, if your host has internet access, NAT allows your virtual machine to have internet access. If you click on attached, we also have bridged. Bridged basically allows your host and the virtual machines to communicate using the same network. So for instance, right now, if I'm connected to the company LAN and I select the bridged adapter, this virtual machine I'm creating will actually get its IP from the LAN and will be accessible from the LAN and will be able to communicate with other machines on the LAN. Now, if I select bridged, you will see under name, I'm basically told to select which interface I want to bridge to. So I can go with my LAN, I can go with my Wi-Fi, depending on what I have. All of these have their different use cases. Hopefully, I will be sharing also those use cases in a few. Then we have internal network. So with internal network, the virtual machines get to communicate to each other. Only the virtual machines. The virtual machine will not be able to have a network connectivity with the host itself. It also has its own use case. Then we have a host-only adapter. Now with host-only adapter, basically means that the virtual machines can communicate with each other and communicate with the host. However, they can't communicate with the rest of the network. Let me illustrate bridged internal only and host only adapter, because I know some time back it used to give me challenges trying to figure it out. So going back to our network here. So when we talk of NAT, in most cases when you talk of NAT, you want that particular node to have internet access. So this guy here, let me call this gentleman or lady here the host. So when you talk of NAT, basically means that my host A, if it needs to get internet access, it will have to ride on the connectivity of my host. However, host A can't directly communicate with my host. Sorry, the virtual machine A can't directly communicate with the host. It can only have internet access. Also, my host can't directly communicate with the host. My host can't directly communicate with my virtual machine A, though technically you can figure a few things out, but by default, out of the box, they won't be able to communicate directly. So that is NAT. With NAT, main aim of NAT is basically allow this particular host A to communicate using resources attached to NAT main aim is to allow my virtual box or my virtual machine A to communicate by riding on the connectivity of my host. So if my host has internet access, my virtual machine will have internet access. If my host can access internal LAN, then my virtual machine will also be able to access that particular resource, that internal LAN. However, anything that any other machine within the LAN won't be able to directly communicate with my virtual machine. So in a way, it basically puts your virtual machine behind some block of sorts. and at times it can actually shield that virtual machine from being accessed directly. Now, going to bridged. As I mentioned, with bridged, my virtual machine A and the host will now communicate on the same LAN. So if my LAN was 192.168, it means my virtual machine will get an IP on the LAN. It will be able to communicate with my host because the host is also part of that LAN. My host will also be able to communicate with the virtual machine because they are on the same LAN. Now, if I have other endpoints here in the organization, the virtual machine A can directly communicate to all of them. And they can also vice versa communicate with the virtual machine without having to go through my host. Remember, with NAT, all of these guys will ideally will have to go through the host. So with bridged, that's typically the main difference when you talk of bridged. Now, when we talk of internal, with internal, only these two nodes, only these two virtual machines will be able to communicate with each other at a network layer. They won't be able to communicate with the host. So if you are maybe playing with the malware and all that, you ideally want to use internal. Then the other one was a host to adapter something. So host only adapter. See, a few guys have raised their hand. I'll be coming to them in a minute.
Lawrence, maybe I could just interject slightly.
Yes, please.
In your diagram, could you use a different color for the different processes, like for host only, so that we can know the difference which is which?
Yes.
So maybe you can say red for host only, bridged blue, and a different. So it will be easier because right now, if somebody sees this, it's quite confusing.
Yeah, and this is being recorded. Yeah, it will be quite confusing. So yes, I will actually still come back to these to illustrate this practically. But for now, I just wanted to do a brief, which is actually it's not a brief because it has taken a while. But I'll still come back to this, factor in Labu's comments and just color code these communications.
It's fantastic. I'm liking what you're doing. It breaks it down and makes it simple.
Awesome. Thank you for that. So when we talk of a host-only adapter, so let me open a new thingy here. Don't save. So host-only adapter, we still have our two servers here and our host here. So we still have A, B, and the host. So when you talk of host-only adapter, this communication will be limited between host A and B. So what will happen will be the host can communicate to A can communicate to the host, B can communicate to A, and A can communicate to B. The host can communicate to B, and B can communicate to the host. Now, if we had other servers around, these servers won't be able to communicate with any of these. So they can't communicate with A, they can't communicate with B, and all that. So host-only adapter is limited to only the host and the virtual machines within that particular host. Think of host as a LAN that is specific for that particular virtual infrastructure. Now, when you talk of a LAN, it means you can have multiple LANs. So hopefully I will also be able to share that. Now, going to our explanation, something I was forgetting. With host only adapter, you don't have internet access. That communication will be limited just between A, B, and the host. So nothing gets out of at this particular host. In most cases, you won't have internet access. So going back to our VM. So one of the tricks I typically use is when I start deploying the VM, I usually go with NAT. Now, reason for this, and I'll just share the strategy. So we are meant to deploy to have how many machines? Two virtual machines, A and B. Recall that mental roadmap, mind map you have. I know that these servers are basically meant to have either, let's say, they're meant to be web servers. So what I'm actually going to do, if they're running the same OS, I will focus on one server only, give it NAT access, update it, install the applications that I require. Once I'm done with that, I will take a snapshot, take a clone, and once I've taken the clone, then after the clone now, I can start figuring out the networking aspect of things. So right now, using that same approach, I'm going to go with NAT and just focus on this first server alone. Then I'll be able to show you how to do the other aspects. So taking snapshots and all that. Still on networking, you can see I have multiple adapters. So I have adapter 1, adapter 2, 3, and 4. So this adapter will be based on the kind of adapters you also have on your virtual machine. So if you want your machine to have multiple adapters, you can't play around with this. But today, given that it's meant to be introductory, I will be just focusing on a single adapter. Now, you can enable and disable an adapter. An enable adapter is similar to having the cable plugged in. When you disable it, it's similar to having the cable unplugged. Then we have advanced. With advanced, you can basically select the adapter type. If you have multiple adapters, you can toggle either you want this to be promiscuous, depending on what you want to achieve. Importantly, you can specify which MAC address you want to use. So you can hard code your MAC address. You can refresh and generate a different MAC address depending on what you're working on. Now, I know I might forget this. Changing this MAC address is very important. Reason being, at times, when you clone your server, you take a snapshot, at times these MAC address don't change if you're not very deliberate with it, and also depending on which virtualization software you are using. So if they don't change and you introduce this into your network, then you end up with two servers with same MAC address, maybe requesting for the same IP, which can really cause havoc. So best practice for me is just to ensure I regenerate MAC address, though we'll also see this when you're cloning, VirtualBox will give you an option and ask you whether you want to retain the MAC address and a few specifics. We have port forwarding. So port forwarding is basically what I was talking about when I say that as much with NAT, there are technical ways you can access the virtual machine behind the host. Typically, you want to do that during with port forwarding. Maybe in a later video, later session, we probably will do a deep dive into the various capabilities. Then cable connected, you can still disconnect the cable. Actually, cable connected is similar to plugging in the cable and unplugging the cable. So you might have your adapter enabled, but the cable unplugged. So for us, we let it continue as plugged in. Then we have USB. If you want your machine to have USB capabilities, you can go with USB. Importantly, we have the shared folders. Now, at times, I know many times, I'll have certain resources on my host that I want to be able to access, or that I want that particular virtual machine to be able to access. So for instance, when I'm working with the Windows machine, at times I'll find that I have documents in my host that I want that particular Windows machine to have access to, or that particular Windows virtual machine to have access to. In that case, you want to come to shared folders, click on start, or click on this plus folder, specify the folder or the location of that folder. So in this case, I can say maybe Postman, then give it a name, determine whether you want it read only, you want it to auto mount, then specify a mount point. So for me, depending on what I'm doing, at times I won't want my virtual machine to edit the folders or the files in the folder that is on my host, in which case I will mount it and make it read only, which means that when I'm in the virtual machine, I can only read those files, but I can't edit them. For now, I won't be going into a detailed deep diver. Hopefully in the next sessions, we might be able to do that. So with that, our system is okay. We have gone with NAT. We should be okay now to start. So I click OK. Once you have clicked OK, then you click on Start. So under Start here, there are multiple options. For now, let's just click Start. Later, if we get time, we might be able to show the normal difference between normal start, headless start, and detachable start. So I'll click on Start. So when I click on Start, I should get a pop-up. So I'll get something similar to this. So most recent version of VirtualBox will give you something similar to this. So it basically asks you where your startup disk is. So this can be that particular ISO file you downloaded for, in our case, for Centos. It can be the ISO file you downloaded for Windows. It can actually be a disk or a USB. So once you get this, you select the ISO file where it is located. So if it's a drive, you'll select the driver depending on what you have. In my case, I had already added it. It should be somewhere. Here it is. Now to add it, you basically click on this icon here. Then, given that it will no longer be existing, you want to click on Add. Then once you click on Add, navigate to where that particular virtual ISO file is. Then select it. So for me, I'd already done this, so I'll just, in your case, you want to select it, then it will appear somewhere here. Now once it's there, then it's just a matter of selecting it. Once you select it, we click on Start. And once you click on Start, this is the interface you should be able to get. So you'll be told you want to capture, just click on Capture. So capturing basically means that once your mouse is within the virtual machine treats it as its own mouse. I hope that makes sense. Not as its own mouse, it helps you interact with the virtual machine via your pointing devices. So the mouse, the keyboard, without having to, I'm trying to find the right words to explain this. Hopefully it will make sense. So the moment I capture, if I do any operation on my mouse or on the keyboard, they will reflect on the virtual machine and not my host. So for instance, if I scroll down, These you can see the changes. So because I've captured the mouse and the keyboard. To uncapture and now avail your mouse and keyboard to your host, if you are running Windows, you want to click on the right control, and now I can move my mouse out of this. So I'll go straight to it. Don't show me. I capture it, and we install Centos. Now, the moment you click install Centos, then from there, you basically do the typical operation you will do when you're installing an operating system. So let's let it load. So something I didn't mention when it started off is we have different softwares you can use for virtualization. So we have the most common ones are VirtualBox, the most common ones, and user-friendly, though user-friendly also depends in regards to your capabilities. So I'll say most common one and very beginner-friendly. We have VirtualBox, we have a VMware Workstation, then we have a Windows Hyper-V, because Windows also comes inbuilt with the virtualization software. In some versions, you have to go to Windows features and manually enable it. Apart from those three, we have other technologies like I think KVM, KMU, Proximax or Proximox. We have a few things out there that you can also use depending with what you want to achieve. So from here, just typical configuration steps, the language. The first step from experience, you can leave it default because most of these ISOs will pick the keyboard and the language based on your location, especially if you have internet access, and also depending on the time zone VirtualBox has picked. But you can change it and maybe go to Amharic, Arabic, depending on what you fancy. So you click on continue. Okay, so once you click on continue, you can change the localization again, language support and all that. Most importantly, now if you are using Centos minimal, the beauty with minimal version is it is very small, less than 1 GB. The disadvantage of it, especially the latest CentOS minimal ISOs, is in most cases, it requires you to have internet access in order for it to download a few things here and there based on my experience. So the first thing you want to do is come to network host, click on it. Right now we can see it is disconnected, so you want to switch it on. Now, if you don't switch it on, you might be able to proceed with the installation, but depending on which version you are running. If you're running minimal, you probably won't be able to proceed with it. If you are running, if maybe you installed the full Cent or ISO, which I believe is usually more than 2 GB, you will be able to proceed with that. But once you've done your configuration, you have to manually enable these. And at times, if you're not used to this, it can be a pain. So just ensure you come to network and ensure it is enabled. You can still go ahead, change the host name if you want. In our case, there's no need for that. You can click on configuration, maybe change a few things. If you want to use a static IP, you don't want to use DHCP, you can still play around with that. In our case, just enabling this should be enough. We see we get an IP address, which is still part of NAT. We get DNS and a few things here and there. Once that is done, we click on done. The other thing you want to do is come to installation destination. Now, in most cases here, if you're just starting out, go with the default. The beauty with the default is right now most virtual machines they do what we call LVM. So LVM allows you to come later and extend your hard disk, increase an additional space. So if you're just starting out, just click done, and most cases you will be okay. Now, given that you have internet access, network is enabled, now we need to select our software. Now, given that we are interested in a server, I will go with the minimal server and just specify done. Now, nothing is stopping you from choosing any of these other features. You can choose workstation, you can choose server with GUI, but I usually prefer going with server without a GUI. Then once you're done with that, you click done. You go to the root account, set a strong password. So which strong password can we use? So I'll just set something dummy there. Then, well, ideally, you want to use a strong password. Then still from here, you can decide to also create a non-root account, maybe something like something with your name. It's up to you to figure that out. Once you're done with this, then you begin your installation. Now, this installation is going to take a while, depending also on your internet connectivity and all that. But at this particular stage, you typically don't require to do anything. It will run to completion. Once it's run to completion, it will tell you reboot system. And once you reboot your system, it will be done. So in the interest of time, once you reboot the system and you're done, what you'll end up with is your server running, not powered off. So in my case, I actually powered off that particular server. Now, once I've powered it off, I've done everything I wanted to do. If I want to reuse that particular server, instead of having to go through that whole process, what I'll typically do is power that server off again. It appears somewhere here. So it will appear something similar to this. Right click on it, then clone it. So clone is at the top. So cloning is basically copying that particular server. So once I clone it, I can call it CentB. Then I can specify full clone, linked clone. In most cases, for starting, just use full clone. Keep the current machine state based on the snapshot you have also taken. Then right here, you can decide whether you want to keep disk name, you want to keep hardware UIDs and everything. Now, in most cases, we don't want to do that. So I always advise that you go with the defaults. So I'll go with the default and just click on clone. So depending on the size of your server, cloning can take anywhere from a few seconds to a few minutes to an hour to actually a few days. I've seen a server that took a couple of days to clone. Now, once that is done, you have your server ready right here. So with that, we can click on any of these servers and just click on start, and our server will start booting. So I've clicked on start. It will display a page for me, and we can see right here it is booting. Apologies for the background noise. So you give it a few times for it to boot. So eventually, after it boots, it will prompt you to enter your username and the password. Now, depending on the name you created, so if you had a root account, you will enter the root account, then press enter and enter the password. Let's see if this other guy has completed. He hasn't completed. So in a nutshell, that is basically how you set up that particular server, and you start creating your first machine. Then you clone it and you proceed. Now, something I wanted to show here was at one point, or once you have made the changes on your first server, you can take snapshots. So what a snapshot basically means is that you are telling VirtualBox to retain or to save the state of that particular server. So for instance, our server is running right now. Let me just rephrase that. We created our server, we update it. Once you have updated it, you haven't installed anything. To me, I typically like calling that our clean image, my clean image. I might mess up my virtual machine later and might actually want to return to a clean image. Now, typically, if I do that in my machine, if I completely mess up my machine, my physical machine, I probably have to reformat it. Now, virtualization does it in a more better way by taking snapshots. So this clean image, I haven't made any changes. It's what people will say vanilla image. Can click on it and just say take snapshot. So I take my first snapshot, I call it clean, and I click OK. Now, with my clean snapshot, it basically means from this state here, if I install a virtual machine, if I install any software, I infect myself with malware, with ransomware, I can go to my snapshot, right click on it, and say restore. A restore here, let me see. Restore is disabled because the machine is still running. But if it wasn't, it's possible for you to come to the snapshot and just restore this machine to that particular clean state. And you can take multiple snapshots, as many as you feel like. Disclaimer here is snapshots occupy memory. So the more you take, the more storage, hard disk storage, is going to be utilized. Now, once you have multiple snapshots, so I can still come here, take another snapshot. You can also delete those snapshots. So maybe I'm sure that, okay, I need snapshot 2, I don't need snapshot 1. I can go to my first snapshot and just delete it to save some disk storage. Depending on the server you are working with, snapshot can actually take and consume a lot of your storage. Now, once everything is done here, it will be possible now for you to go back to, for instance, settings, and now play around with, so for instance, your networking. So if you are using NAT, we can go and use bridged adapter. We can now go and use internal adapter and so on and so forth. Now, with that, I see this is still taking a while, and full disclosure, I would have loved to proceed with practically showing the networking aspect, but unfortunately, and this happens a lot of the time, I don't recall the passwords I set for these two for my Cent and Cent2 machines. I think it's one of the side effects of not using a password manager and setting unique passwords. But hopefully our organizers will be able to allow us to continue this maybe in next week's session, and probably I will be able, if I will still be taking you through this, I will be able to take you through now the practical aspect of basically doing the networking. So show you how you can still use NAT to even ensure there's communication between those particular machines, and also show you how you can use a host-only adapter with that. Now, before I hand the program back to Michael and give the reins to Chuck just to do a few things. So Michael, I should be handing the reins back to you in 5 minutes. Just for guys who might want to go a step further, if you want to use the host adapter, host only adapter, recall that I'm trying to find my paint. Here we go. So if you want to use a host only adapter, recall host only adapter is these green guys. So this guy, this guy, this guy. We mentioned that host only adapter is similar to LAN. So if you want to configure that, you want to go back to your VirtualBox, go to File, and go to Host Network Manager. Now, depending on the version of, if you're running the latest version of VirtualBox, you will see something similar to what I'm seeing. So if you come to Host Network Manager, if it's your first time, you probably won't have anything here. So you basically create your own LAN. So in that case, you click on LAN. So you click on create. After clicking on create, it takes a while. We can see it right here. Then once you're there, your LAN has been connected. Think of this as a switch. So you have your LAN switch here. Then you ideally want to enable it. Then after enabling it, you can now go ahead and configure it. So you can either go to properties. I was already on properties. Then you can see the LAN that you have. So for this particular one, adapter 4, the network range I have is 192.168.11.1. I can specify the DHCP server. So DHCP server basically means that this adapter will automatically issue IPs. So I can configure a few things, basically say the server address is 2, determine which IPs I want to be list. So I can even say that only list IPs from 100 to maybe 103, which means that only 3 IPs will be listed by my DHCP servers. I failed to save. Okay, what's the error here? Invalid range. Okay. There you go. It is enabled. Now, once that is enabled, if I come back to my settings here and specify, go to network, specify host only adapter, I should be able to see my host adapter 4. And right now, the networks that the range that I'll get in my virtual machine will be actually along that particular line. So going back to paint, so what you'll end up with is any new host that I add, any new virtual machine that I add and connect it to that particular adapter, they'll all be in the same LAN and they'll all get that particular IP and they'll be able to communicate with each other. Importantly, the host will also be able to communicate with all the various LANs or the various host only adapter you actually create. So the beauty of that is straight from my host, if we are running Cent, so straight from my host, it becomes possible for me to easily SSH to any of the virtual nodes I might have created. Then with that, I would like to come to an end for this session. We are definitely going to have another session. Now, for the next session, we are going to have the assumptions we'll be working with will be that your virtual machine, at least your CentOS server, will be up and running. So as you can see, mine is still running, will be up and running. So we'll just go to cloning, taking snapshot, and spend time on just sharing the aspect of networking. Thank you so much, everyone, for feedback, questions. I haven't seen any question. If you have any questions, please, I'm available in chat. You can use this time to ask any question or seek any clarification. Michael, I would like to hand this over to you. Oh, I see also Jones is around, if Jones is also available. I also saw Chuck's around. Chucks, if you're also around, you can also.
I'm nearby. I'm waiting for Mike to just close it up so I can go to my session.
Okay. So I'll just stop sharing for now. Chucks, I think as we wait for Michael, yeah, you can just start, maybe, I don't know, do the introduction and take over. Michael will align with us at a later stage.
All right, roger that. So I know time is out, and also it's a Friday. People are going out to go to enjoy themselves. I know Netflix has dropped some new shows and a new movie, so I know guys are just want to go home and relax. So I'll try my best to make sure I don't take much of your time. We had asked that guys ask questions so that I don't have to go to a full new class, so that I just answer some of those questions that were requested. So I'm thinking that's what I'm going to look into. But there's a question that came earlier, which I think I should look into first, because I talked about it. There's this thing I talked about, which is called the computer network stack. When I say the Stuxnet and others, like the new one, which is Whispergate. So a lot of people don't know what this Whispergate is. I'll use Saber Regis for this part of showcase. So let me just log in there.
Systems online.
I'll share my desktop now. Hang on, just stand by there. Right. Share. So Whispergate is like it's a kind of a destructive malware that, or rather, destructive toolkit that was used by Russians to destroy Ukraine, to try to destroy Ukraine government, and to try and destabilize the Ukraine, and also fake the whole intrusion to look like it's Ukraine attacking itself. So what happens is that, actually, let me just log into one of the database 3 rules for Cyber Ages. This is usually internal. So I'll go to the, yep, there you go. So what happens is that you have the stage 1. The stage 1 is the one that actually goes ahead and wipes and messes up the NBR for the hard drive. Then you have stage 2. Stage 2 is a loader, which by this time, according to the guys, is that it actually helps to pull an image or IMG, or I think it was a JPG from a Discord URL. Then it drops at stage 3. Then at stage 3, it encrypts it actually wipes the files inside the hard drive. So by the time someone is leaving for work, he's leaving the evening from work, he doesn't know the machine is already at a wipe. So when he boots up, or he or she boots up, the next day he gets this message, and this is the one you're seeing here. All right. So for those people who didn't understand what Whispergate is this how it looks like. For it was meant to go in wide scale inside Ukraine, especially Ukraine government, but Microsoft were able to stop it in time. All right, so I'll go to the questions that were asked earlier. So let me share my desk again to make sure that I can actually get that access to. So I didn't receive as much questions as I expected, but it's okay. We can always ask them later. So today is mostly going to be just a QA. I'm not going to go further into details about other things. So one of the questions was that why do I need to learn? Where do I learn C and C++? So back in the days for us, when we were learning these things that we didn't have as much material as right now. If you want to start, I think the best place to start is places like Udemy. Don't go to YouTube to start learning C. Most of the time there you find that those people who are doing trainings there are not doing a full class training because it's open source. But if you go and buy a class, like a place like Udemy, or these are places where you buy classes, they give Microsoft of a class where they train C and C++, learn from them from scratch in a way that you understand all the way from variables all the way to pointers to heap so that you don't get lost, and start from C before you start C++. But the thing is that on RTO and also CNO, we combine them together. It's just like you say C# and .NET in CNO and RTO, because you combine them together when you're running operations. The thing about C is that it's low level, it's really good, and you can actually be able to interact with the kernel for both Linux, Unix, and Mac and Windows. And that's the amazing part about being in a position to run C. The other good advantage of learning C is that after you learn C, all the other languages come like rain. You just flow. Okay. Expect high level languages like C#, Python, Node.js, Golang. All these other they usually just come very easily because you don't need to dig deep on it. You just look at a few functions. You're like, yeah, I get what's going on there. I can write this shit. So C is very important. The other part is it's also very important to learn assembly, ESM. So ESM is also adequate for both NASM and MASM. You just have to choose and learn both sides to understand how to do some things like shell code, all those kind of things. All right. Yeah, I think I've explained this part. It was part of question 1. I think, I don't know if there's anything I've left out on that. So in case there's anything I've left out, let me know. There's another person who asked a question about where I talked about pushing an NZ, or rather pushing another executable inside another executable. Well, this is different because most adversary should do this. It can be a form of infection, or it can be packing. So most of the adversaries these days, what they do is what you call packing. They'll try to encrypt the binary and put it in a section inside another PE. And then when the PE runs, it checks whether it's being checked by a debugger or someone is looking at the processes. And the funny thing is that the first executable doesn't have much. The only thing it does is just some bullshitting on the computers. It looks like it's doing something good, but it's actually packed with another PE inside which is encrypted. And when it realizes it's time to load it, it just loads it and executes on target. And you find that most of the ransomware guys usually do this. So let me do this actually. Where is my? Let's go to PNC. I'll just use the machine we're using before. And what I want to do is check the IP address. I can see properly from where it is. It's the other side of the desk in my home office. 112. So let's go and set it up. 112. 112 and bum, 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 bum. Don't worry about me. My machines, I'm always coding all the time when I'm having a chance to. So it's 112. Let's log into it. So I'll just demo how it looks like. I don't know if you have time to write code to showcase how a loader will use parking to drop maybe ransomware. Like most of the ransomware guys, this is what they do. Also, some APTs will do this a lot. So I'll just show you how it looks like. So, so if you have a file, and let's say, so we'll take one of the files that we have made. Sorry, it's supposed to be on users. I need it here. How do I get it there in time? Source records. Is there a way to make it to actually make sure that it has a pin to access? Awesome. So what we were looking at last time was get path. So I'll go to debug and I'll copy. Let's say this is the implant that's supposed to do manenos in your machine. So this actually just gets the path. All right. So what you have is maybe calc. Let's use calc. I like to check this. I'm not using it right now. So this was 64-bit or it was a 2-bit? Anyone remind me? It was 64-bit. Okay, let's confirm. Just confirm. Where's my process hacker? Get path. Boom, boom, get path. Properties. I'm hoping everyone was able to practice and do some of these things. All right, so we are going to be working with that 2-bit piece for now. So now we want to get a 2-bit version of what we call maybe calc. So let's work with calc for now just to demonstrate how it looks like. So system that Windows that x86 will be here, which is a 2-bit, and what you want to look for is binary. And this is the 2-bit. So we want to go ahead and copy it. Let's copy it to our desktop. And yep, let's work from there. All right, let's close this. So by default, if I right click and I say open up with Safe Explorer, you'll notice obviously it's a full NZ. It's a real PE, operable executable. It has the NT headers, all the way that connects to file header. These are some of the things we might need to actually understand. Like if you look at characteristics, you can see that it shows you the file is executable, file is a DR, what type of file it is, what type of bits it has, all that stuff. So these are the characteristics where the file headers information on the characteristics are kept. But most of the time, you find them initialized here for alignment. These are some of the things we're going to understand when you're writing a packer or anything like that. So the thing is that you have all these resources about the directories. Then you have hex here. So if the file is actually UPX, it will tell you it has been UPX. You can actually even unpack it from here. It gives you the hex data information. It tells you to start from here, like we said before, and it is 5A4D. And because of Indianness on assembly, it starts from, it actually interchanges them because it reads from right to left. So let's say bad guys, what they've done is that they want to add something here, a section to hide the PE. So what they're going to do is add a section. And let's say, sorry, we make an empty section. So let's make an empty section and call it, let's give it a space for now to make sure that we have it. You can see right now it doesn't have anything, just a little bit of information on virtual size, virtual address, a little bit of row address information. Those are just things to help the section you have made have some alignment. You can add a file. So the file you're going to add is one we have already made, which is getpath.txt. Right now, if you look at this, when you add this, you'll see that actually the size of this file becomes a little bit bigger. So It's 39 KB. So let's put it there so that you can see properly. And we push it there. So the file that you're going to add information is this one, which is 26 KB. And if you add it right now, if you open it up, if you add the executable, you'll notice we have another section. So let's just make sure that we give it a name, data. Let's remove the empty one because we don't need it. So delete section, header, and data. And you see now, if I click on this section, you see I have another MZ there. So in short, the file will have two MZs. So actually, if I save it, I can save it as whatever it is, yes, and overwrite it. And if I close it and I open it up again with Explorer, you will notice that it's the same file, only that on my sections, I have a new data section, which has an MZ in it. And I can dump this section, and I say test.exe. And this text.exe, if I go to it and double click on it, you'll see it has the MZ that you already attached. So bad guys is what bad guys will do to try and make you think that they don't have anything inside. But if you actually look at a section internally, you'll notice that you have that information there. So let's take an example with one of the toolkits I've been working with a lot. I usually work a lot with ransomwares to actually look at how they are developing stuff. So I'll still use Cyber Aegis for this one. So I'll have to close my share. If there's any question, I think this is the best time to ask before I go further to ranges. Any questions? I think we're going to use a threat. Which threat we use to look? Okay, let's look at the last one I looked at before so that I don't have any confusion. We're going to look at Ragnar. All right, here we go. Is there any questions before we continue? I don't leave anybody hanging out. I know it's late and we are doing a little bit of weird stuff. All right, so share desktop again, and we go and look at that. All right, as we said, new MZ. All right, we're going to look at the same thing with Wagner. So by default, if for those people who actually do threat intelligence like I do, and you have noticed the latest one is called XNormal. Right now they have a new one which is called XNormal Copy, which was I think compiled sometime on December 12th, I think, or December 1st. Can't remember well. It's a normal PE, and it's really just because actually it encrypts your files to and gives you a .dot. So what I'm going to do now is that we're going to look at this binary, and you see it has what we call another MZ. And for us to do that, I need to make sure that the file is on debug, because what happens is that when this file is on debug, it stops executing. And I'm going to use either. And from either, I'm going to drop it there. So, boom, boom. Oh, okay. Is it there really? No. Yeah, it's there. All right, let's open it up. What are you saying? Okay. And what you're going to do is that you're going to look at the exports. You can see it has the normal export for starting up. And what you're looking for is virtual allocate and what's the other one called? There's virtual allocate. Okay, let's just look for them.
Create
What you want to do
remote
is
thread.
Yeah.
Create remote thread.
Not create remote thread, not create remote thread. You want to look at the virtual allocate and virtual protect, because these are the ones where the internal MZ is now supposed to be opened and run as shellcode on target PC. So we want to look at this, and we want to add a debug on them. So so this one, It's going to do the virtual locate. So if you do the virtual locate, it's going to have another breakpoint on it. So at the breakpoint, yep. So everything to do with that. The other one is virtual protect. There we go. So anything to do with virtual protect, we are going to make sure we add that breakpoint so that we don't execute. Actually, if you run it on an X debugger, you see it just goes quiet. So let's start the debugger. Yes. All right. So it triggers a new issue, but it's okay. So now what happens is that it's going to connect to NTDR, and it's going to take you via a loop of 20,000 times to confuse the analyst. So we don't want to look at that. There's no need of us going through. But if you look at the process, so if you look at the process manager or rather process hacker, look at process hacker and you go to X normal, it's already running. It can't encrypt because it's already on debug mode. It is. We can go to the process properties. No, not properties. Is it properties? Yeah, I think so. Yeah, threads. No. Modules. No. Obviously, you can see it's actually calling NTDR right now. It's very active on NT layer, and Canobase, and also Canal2 will be called. I'm looking at something that supposed to handle my PEB. I don't know where it was. Yeah, it's because I'm looking at it the wrong way. All right, so memory, when you look at the memory, you can see if you continue running until all the way it goes to virtual protect, where it's now opening up the payload, you'll notice some of these parts where we have the read, write, and execution. It will have a much more space emulated and ready to drop a new MZ. So we're not going to look at that right now because we're not doing a malware analysis. What I want to show you now, because it can't execute because the thread is already there. What you want to do is just right-click on it and open it with CF Explorer. Don't do this at home. Make sure you're on a safe environment. So actually, if you look at, obviously, the DOS header is a normal MZ. If you look at data directories, if you all the way go to section header, you can see there's a section. There's several sections here. So there's a text section where the code is. There's other data where the other code is. Then we have data where we have another MZ, which is mangled with other things on top. You can see that? So they are actually kind of doing some level of relocation and alignment and also correctology so that they can hide the MZ internally. So this MZ when it drops, is the one that actually runs encryption. All right, let's try and see if you can dump it. So I'm going to go ahead and do a dump of the section. And I'm going to drop it maybe in a folder. Let's call it, let's make a folder here. New folder. Call it dump. And inside here, you can call data.bin. All right, so we have data.bin, where we have now the MZ, which is having a mangled alignment of virtual size and other characteristics. So I'm going to go to it and dumped. And I'm going to go ahead and open it up with the hex editor so that we can actually be able to look at it. So what I'm going to do is I'm going to look for a hex editor. I don't know where my hex editor is. It must be here because this is a threat analysis machine. It should be having all that stuff installed. So I'm going to open the hex editor and I'm going to open the threat, which I've dumped from the MZ internally. This is just a simple way of doing it, but there's actually a better way of doing it, which actually takes a little time. So dumped data bin, open it up. And what you want to do is, like what you discussed about MZs, you want to make sure that it starts with the MZ. So we don't know whether it's an executable. We don't know whether it's a DLL. So it's up to us to figure out. So delete that and save the executable. Save it. So for us, by default, we are going to be thinking is a .exe inside, but actually for real, it's a DLL. So if I click dump and I go to where the .bin is, and I go ahead and rename it, and I'm going to call it an exe. And after I name it, what I'm going to do again is going to go and look at it with a saver to know what type of PE it is. So I'm going to go ahead and open it up. So dumped, and I'm going to open the exe to see what type of exe it is. You can use on command line. You can use a file, something like a command like file. It will tell you the same. So if you scan it, it will tell you it's a DLL which has been made with Visual Studio, like the Visual Studio we're using. All right. So you can go ahead and now change it to a DLL. This is what we call unpacking of a PE which has already been mangled up and messed up around with by these guys. They like doing this a lot. So they run it with run DLL, it opens up. So let's open this DLL, we see what it looks like. So don't save. I don't want to save databases for this. I just want to open a new one. And we're going to open the dump file. And it's going to be on data.dll. And open it up. And it's a PDLL, as you can see. And then it will give us a few errors because we have not cleared up the alignment properly. You can do that with PBA. PBA is one of the best tools for actually getting that done. Because this is not a malware analysis class, I'm not going to go and showcase fixing those virtual stuff. So yeah. And there you have it. And you can look at the imports, you can look at the export as it loads and all that stuff. And because of the alignment is not well done, we may not see everything that we're looking for. But the DLL is there for you. It showcases a lot of things that it's doing. And you can actually be able to find a lot of stuff that these guys do when they're creating ransomware. All right, any questions so far on those guys who want to know about packing? Do you want us to do like a class where you showcase the whole packing from start to finish? Yeah. Or we go to the next question because time is against us. I can see guys are saying they're floating. If you did not go through the class that we did last week, you might float. You have to make sure that you went through the class we did last week so that you can understand what we are doing. So if you did not do that class, I think you make sure that you do it and you ask questions as soon as possible so that I can come back and showcase from there. All right. There was the last question. I received only 4 out of 5. So I'm going ahead and share my screen again and allow. And I'm going to go to this. I don't know if I can, you can see my screen here. Awesome. All right, so I'm going to go to create from start again and go to the last question. Do you have to install Visual Studio? Yes, you know, you have 2 types of Visual Studio. There's Visual Studio Community and Visual Studio, the one that comes from Microsoft. Also, there's another Visual Studio that actually is open source that you can use on Linux, Unix, and Mac, and also Windows. They're both helpful, but Visual Studio Community is good because of Visual C++, because you want to be able to write toolkits, like what you were doing last week, where you write toolkits which are interfacing with Windows kernel and Windows API, other NT API and Windows API. So it's important to make sure that if you want to learn and be able to use the capability, it's important to have that. Otherwise, if you just want to make simple scripts with C, you can use GCC. GCC can be installed on code. It's called code blocks, and also it can be used on Visual Studio, the open source version, to run operations. But for me, I usually like when I'm doing anything to do with writing code for implants loaders, just like you have seen with Ragnar team, they're using Visual C++ to make the DLL. So if you want to become a better operator, Visual Studio is a must. All right, I think those are my questions. In case you have another question, in case you want us to go look at how to develop parking capability when you are hiding your MZ inside, let me know. We can do that. But that requires that you understand the alignment of characteristics. You need to understand PE and PE imports. You need to understand directories and other things that might be important for actually working with a PE header. So yeah, I don't know. If there's any question, I think that's it for today. Yeah.
Can you hear me? Am I audible?
Yeah, go ahead. I got you.
Okay. Now about the C++, how to append shellcode. Is it possible to showcase today if we have time, or should we push it for the next session?
Chucks, could you please unmute your mic? We are not able to hear you.
Oh, sorry. It happens. Today I'm very exhausted today. So I might make a mistake or two or one. So in case or anything, just let me know. All right, as I was saying, we don't have much time. It's already almost a few minutes to 8, and I know people want to go and enjoy themselves. I know Matadorian is out. The last episode of Boba. And other shows have come out from Netflix today, so I know guys want to go relax and enjoy, the normal geek life. Me too. I want to go and watch the new CIA show about Out of the Cold, something like that. So, all right. So what I want to do is I want to create a new small simple shellcode test. We're not going to go deep on this. We're going to work on this later. So I didn't know I wasn't ready to do this, but let's make it for a simple way of showing the scenario. So we just make a simple way of how you load shellcode with C and see how we can actually be able to work with it. So I might need to have a Putty so that you can actually be able to develop some bash script on a laptop on the network instead of actually joining it on the like I usually do in class, where I join it into the video conference, into the conferences. But for now, I won't do that. I've got time. But next time when we do it, we will have it, because I usually like doing my NASM. I actually like working with NASM more when I'm making shellcode, even if I'm doing it for Windows. And NASM when writing something inside Visual Studio. But for now, I think let's just use NASM on the remote. All right. This is the last time you were looking at DLL. So what I want to do is download Putty. I don't think I have Putty on this machine. Putty. Bum bum? No. All right. Yeah, putty.org. By default, I usually use let's just download the let's just do the installer, because what was it's a problem. It has both the x64 and the x86. So I'm just going to install it. All right, sorry, I forgot I already installed that. I'm literally blacking out here. This week has been hectic. All right, preparing the install. All right, next. All right, install UAC. All right, finish. I forgot to move the don't read me. All right, what do we have? Let's put it ready to run. Yeah, all right, let's make sure we add it down here just next to us. And we pin it up. And we have it on the side. All right, let me pick up the IP address of the machine that has a network here. All right, 192.168.8.122. I don't know the port. Let's start. All right, so open it up. Let's go back again and confirm whether SSH is running. It's a new machine which I got the other day for some of these things. I don't know if I installed the 22. H22. Yeah. Can I ping it? 192.168.8.122. Yep. QnA. 192.168.8.122. Oh, QnA is not installed here. Why is it not connecting? Let's try again. Oh, all right. Just those demo gods trying to show up. All right. So what's the username? Okay. All right. So I'm going to go to cd desktop, and I'm going to make a file here. Let's say shell code test, and let's cd shell code test, and this is what we are going to make our NSM file. So the problem is that this class requires more time, so I'll just do a normal small demo so that you can just go and play around before we go to bigger stuff. So as usual, like we did last time, we're going to make this time we're going to play around with normal console, like we did last time. We did with normal with main. So today we're just going to do with main. So shell test add. So include. As usual, we want to work with Windows API. And this time, what you want to do is we want to actually be able to call what we call just an array. So equals, and this is where we're going to set up our shell code. So our shell code might look like x24, x86 form, or maybe x6c, or maybe x2e, just a demo of how it looks like. But you can see we have an error here because we have not specified what type of char it is. You can see it says the main cannot be used as a global variable name or given C language indicator. So we are going to, first of all, we are going to unsign it. We're going to talk about all these things later on. So unsign main char. Oh, Windows, like that. So by default, what we're going to do is that you're going to make sure that Okay, we're going to make sure that the project is console. So it's an exe. By default, it should have, we need to make sure that the levels of return of the levels of problems and SDR, we don't set in SDR from Microsoft. And then make sure the linker has what you're looking for. It is console, and we apply. Are we on that 2-bit? That 2-bit, awesome. So we are going to actually work with that 2-bit source code. Any question? Any question? Or maybe I read? All right, we continue then. This is just a small demo. We're not going to go very far because it requires at least we understand assembly, and also requires that we understand PEB and TEB and those other stuff. So this is where when you develop your shell code, you're going to actually set it up, and yeah, we're going to fix that later when we get back to doing the right things, to the whole thing. So what we're going to do now is that we're going to check whether I've installed NASM on this machine. And NASM is installed. So I'm going to make a file. I'm going to call it shellcode fast.tsm. And it's going to be at that 2-bit, so bits, that 2-bit. And what we're going to do is make sure that we have a global, so I can have a starting point. And then we develop a section, make sure you give it a section. Maybe the section is going to be just text. Just like what we're looking at the sections when you are looking at the source code from CFF Explorer. Then here is always specify how the start happens. And then here is where now we actually specify how we're going to write it. So obviously by default, we need to make sure that we give it some data that it's going to use. And that's what we have where we actually give it things like variables, things like things that are going to carry the data that we require. So we have to wipe those things. We are going to use EAX because obviously it's that 2-bit. So we are going to make sure that we actually saw EAX so it doesn't have any data on it. And from there, we're going to give EAX, we give EAX what? Maybe 19. It's just normal math. And then down here, we're going to give it a function. And this function is going to be just another addition. Maybe this add, we're going to add maybe 1. Let's add 1. So it can come 20. And obviously, we need to close regret. And so from here, what we want to do is that maybe a small example is make sure that we call this function and we subtract the EEX. We give it we subtract what you already given maybe with 10. So call function. I know you have gone so far. The shellcode part wasn't supposed to be done on beginner level, but anyway, let's just introduce it, and guys are going to go to it. So we're supposed, let's say, to subtract something. Let's subtract something like now 20. Let's subtract 10. Awesome. And now we have a simple custom file. So to actually, because it's a 2-bit, we are going to use NASM, and we're going to specify file is an ELF, that's 2. We're going to use the ELF, 2 because we're not using 64-bit. And we are going to fix this and get an object file. The object file, we call it the same name, but now .o. All right, you have a warning. Function. Oh yeah, I got it. All right, let's go ahead. Let's do ahead. Yeah, it is function. Shellcode. Which one? Yeah, yeah. It's amazing to troubleshoot these things and to get these errors are usually very good to actually understand them. Now we have an object file. And if you actually look at this object file with obj dump, I don't remember how we used to use it. Okay, I think you can call it directly. So obj dump, and we call the object. How do you do it? I forgot. Suppose maybe minus what? Archive. It's assemble. Yeah. Bam. Been a while since I used this. You'll see that we have all the information about the shellcode. And so now what we want to do is make sure that we get this shellcode into shellcode readable kind of data so they can actually push it here. So to do that, what I'm going to do is I'm going to use a tool that is used a lot by red teamers. And what I'm going to do is that I'm going to use bash. And I'm going to, this is why it's very important to run different languages. And what I'm going to do is that make sure that I can be able to go through each part of data and make sure I echo out the shellcode. So by default, bash, let's call it bash esm get.sh. So obviously it's a bin bash file. So bin bash. Hope guys can see it. Can you guys see? Or I'm talking to myself? Let's go back and see if there are questions because I've gone to a different level. Anyone with questions? All right, looks like we are good to go. Sorry, today we can't do much like I expected to do. What I'm going to do is that I'm just going to showcase the little one. But by default, in a real environment, when you're running an operation, if you don't have shell, you won't be able to do what I'm doing. So that's why you find that people develop their shell code internally inside the toolkit. So as it goes through the stages, it's just dropping its own and executing its own shell code according to how it's developed internally, and then does the next orientation and then loads up what's supposed to load. Maybe it's supposed to load the stage 2 loader and stuff like that. So what I want to do is first of all decompile and make sure we are actually looking at Intel, because before what you did was just open it up. We didn't specify -m Intel. I think that's the way you specify it. Always start with a small I. Let me see. Yeah. That's what you want to do for look at the section for the text. So let's go ahead and do that. So we are going to say we want to obj dump, and we want to specify that it's going to be to actually compile, and we also want to see that we want to look at it on Intel level. At the same time, we want to make sure that we have an index. So the index will be called with the 4i. So 4i in. So let's put the index there, and so this will go in, and we close it with a number here as usual for those who have done bash scripting. And we want to make sure that we tell that the index is a file that we are going to load. So by default, it's going to be where it's going to be held at I, the index. So and then what we're going to grep for is what are they called? We need to grep for some data here. At the same time, cut some other data from F2. And what you want to remove is, I don't know what it is called. It's on top of 6. So for I, the index in this file, which is going to be held by, yep, like that. What you want to do is you want to echo out everything, but add in every line, but add an X after every output of the index. So, so we're going to go ahead and oh yeah, we need to close. Forgot. We need to close this just like we do with any other programming. So we want to echo out. You want to echo out everything that comes out, but you need to make sure that you add this. You add this X that we have here that starts up, so you can have a readable kind of shellcode, and it's supposed to actually run against every I. So I hope I'm done it properly. And if that is done, then specify it's done. Close it, and then we just echo it out. Confirm we've done it properly. I think we have an error here. We need to close this. Let's see if we've done it properly. So for E, for I, in object jump, Intel, grab, echo it, and then write it on the here. Yeah, we have done it. You need to make sure what you're writing is from what you have collected from the index. So like that. So then we are finished. We do an echo down. All right. So let's see if you have done it properly. So shmod 7 bash that, and then we just run it. All right, we have an error. Where is that error? Number 5. On grep. So Intel grep. Where is that error? Let's do. The problem becoming this problem being exhausted. Oh yeah, for each. Sorry, this is where I made a mistake. So we need to carry for each, not by the index, but for each file. So each file, and then specify the processor, Intel, and then we cut and we echo that out, and and then we close this. Not supposed to close it. We're supposed to just specify that we are looking at adding just this X, and then we close it. Yeah, now it looks better because we don't have those errors here again. I think they're gone. All right, let's go ahead and do it. Yeah, so now if you look inside, we have the O file. So what you want to do is run this against the O file, the object, and we have shellcode. So what I'm going to do, I don't know if I can paste it directly from Putty to this box. Copy or clip, right? I can do that. Just make sure we are in safe area. Let's just make sure I open Notepad. And on Notepad, what is this? Oh, this was PHP from another class. All right, looks like yeah, it was a mistake to actually copy the whole clipboard. So I'm going to paste my shell code there. Yeah, so by default, this is how it's supposed to look like. This is how you call it. So when you get chance, next time you're going to actually be able to write bigger ASM, and we can actually be able to, if you write a bigger ASM which has more information that you can use to the attacks, we can develop that and then bring it here. But if you want to do open source shellcode that you want to be caught, for those who want to be caught, you can paste your open source shellcode here. I don't mind. For me, I don't like being caught, so I like writing my own ASMs. And then pushing my shellcode directly. So for the next one, we are going to write maybe loaders that are going to execute a certain shellcode, and then that shellcode is supposed to execute the next stage or the next stage like that until you get to the implant. So it depends with time and facilitation of the class. Any question? As usual, as you can see from the demo, you have to learn so many languages. The good thing is that if you learn C, all the other languages become like that. PHP, Java, Golang, all of them, they're just coming straight. You just have to make sure you take C. Take C seriously. Give yourself 1 year of C, right? So I think that answers the question for running C and C++. All right. So I think that's it then, if there's no questions. So far, those who have done classes already, I think you have noticed that level of how we write shellcode. So those are simple ways of writing shellcode or working with shellcode. The other levels we are going to discuss later on when you get a chance, like when you're looking at things like effective loading and other ways of things like process hallowing, where you might need to actually write your ASM inside your loader as you go for launch, so that maybe it can process hello to the next one, and you can know when it's actually going for 64-bit process or when it is injecting to a 2-bit process. Those are some things you might look into, but it depends when you're going to get a chance of doing so. Anyone else with a question before we heard about Michael? All right, I think then that's it. Michael, thank you for the day.
Hey, Chuck, this is amazing work. And we really need more time to be able to learn more from you. Just a minute. So, when would you like to have more classes with us so that we can be able to learn more from you?
The problem is time for me. I'm hard right and left. Sometimes it just becomes harder for me, but we are going to always find a chance to come and join up. Like last time we came on a Saturday because the whole week was hammered. Next week, I don't know how it's going to be, but obviously from what I'm seeing from the emails and stuff, things are going to be crazier than this week. But if I get a chance, I'll just holler at you and then we can see whether we can actually get it. Yeah.
Because what I've seen from your approach or from your code, you can be able to create custom shell code. Instead, because what people usually do is that they use something like MSF Venom or Metasploit shellcode so that they can be able to get connections. But the problem is that some of those shellcodes are usually very noisy, and you have to use extra measures to create obfuscation. But yours, you have explained how to create that shellcode through assembly.
Yeah, if you're doing QnA and you don't want to be caught, let's say you have a terrorist guy who's using a laptop in Mombasa and that laptop is installed with Kaspersky, you don't want him to know you are there with you. So you gotta make your SM so that you can maybe do screenshots on his desktop, activate the webcam and stream it, open up his microphone and listen to what they're planning, stuff like that. That way you cannot use the MS Venom and Metasploit and stuff like that, open source toolkit. You have to write your own tools to make sure you bypass restrictions, security. Because we see the security world is making tools for everyone. The bad guys, the good guys, all of them are using the same tools. So if you learn how to bypass them, you can save the country a lot of damage.
Yeah, because I'd really like for you to teach us on how we can be able. So, for example, people who can be hobbyists or people who might want to venture into the world of CNOs or red teaming, they can be able to learn from you and see how they can be able even to develop their own tools, even present them, And you can even guide them on how they can be able to develop the tools to the best of their abilities, or to better tools than there are available based on the case scenario. And we'd love more lessons from you based on this, because I see we have a lot to learn and we need to even study by ourselves, but we need your guidance. We really need your guidance in order for us to be able to at least be competent enough for us to even expand our expertise and try to work on our own personal projects in order for us to be able to develop such solutions. Let me call them solutions.
Yeah, people usually ask me every day, in the morning, you're taking 1 hour, 2 hours every day in the morning to study. What are you studying? They're like, they don't get it. So I think I would actually put it there, always be at the same time. In the morning, when you are clear-headed, study something that's heavy. During the day, study the other simple things like reports and reading other things. But during the morning, take that 1 hour or 2 hours just to study, just learn something new. And because if you waste time jumping around with people and talking and looking at news and Twitter, you're going to waste a lot of time in your life. And the funny thing is that we are given a lot of time in a day by God. And what happens is that if you waste it doing other things that you have not actually put that, because our brain is very huge, it can handle a lot of information. So just give it that portion of time in the morning, even if it's 45 minutes, learn something new. And then you can use what you've learned during the day to fraction it, whatever you do. Don't say that I'm going to practice doing things in the morning. In the morning, learn. Just absorb information. That's the best time to do it. When you wake up, actually.
Yeah, I agree. So speaking for myself, all I can say is that I'm very impressed, and I hope we'll have more days during the 100 days of hacking for you to teach us as much as possible during the period. And for those who might be interested in venturing into your line of specialty, you can be able to guide us and mentor us through the process, so that you can be able also to be solution providers. And also, I'd like you to share your Twitter handle so that anybody who might be interested in asking you or consulting you, they can be able to contact you via any channel that is available, that you can allow them. Hello, can you hear me?
All right, I've pasted it there. It's on my Jonia. It's the same for all my social media accounts. Actually, if anyone who follows me, should follow back, unless I forget. So I'll follow you back so that you can get my DM. If you have any questions, please ask, because like last week, actually all the questions came yesterday and today, 4 questions. If you had more, we could have done more, maybe. Actually, I was planning also to do a little bit of parking today, because I was asked about that question of parking, the one I've shown with Ragnar. I wanted to do a demo on how you write parking capabilities when you want to hide your MZs before pushing in a loader, but maybe next time we get a chance. I know no one else has asked me about process environment block, because we didn't even finish it last time. I don't know why nobody noticed it. I noticed it that I watched the videos like, holy cow, we did do that, and it was part of the program. So I'm hoping we do that, because that's going to be important for those people who are going to work with, understand how to load programs on a target after dropping an agent. Because by default, you find a lot of people, what they do is what you call They do what they call is just develop when they're doing a maldo. What they do is they develop a maldo, and then they hash it, and then on the hash level they hash the or rather they encode the execution and stuff like that. And if you do that, obviously it will download something from the remote, and then how do you proceed from that stage to load the loader on in memory? So that requires that you understand TEB and PEB.
So we'll create as much. We'll be able. I think because you're one of the panelists or one of the coordinators of this 100 days of hacking, we should arrange more time so that you can be able to cover the topics, because this topic is not that easy, even especially for the beginners. We should create more time so that you can be able to take us through every lesson step by step. And for those who don't understand, at least we can be able to have a collaborative session on our Discord or either on Twitter, so that we can be able to catch up and prepare ourselves even for the next lesson.
Awesome, thank you.
Thank you very much, Chucks, Jonia, and you're a true ninja. And thank you very much, everyone, for attending this session. It has been a pleasure and an honor to have you guys participate. And if you have any questions, please feel free to ask Chucks, Jonia, or Lawrence, or any of us. And please also fill in the feedback form, give us your opinions, and even if you have any requests, please don't shy away from telling us what you want to learn as we proceed, as we go on. Thank you very much, everyone, and do have a blessed evening. I think Chucks is the one who's supposed to now end the session, because he's the one who's been in this session and taking us through the session from till now. So Chucks, over to you.
I can see there's a question. I don't know if I should do it today. It's about EMS and Maldoc. So for me, I usually tell people usually not a very good idea to do Maldocking. We leave that. Let's leave that to, unless you are testing for maybe a client to actually be able to showcase how Maldoc works. I usually tell people not to do that when you're doing CNO. But sometimes once in a while, red team, during red team, you want to try to see whether someone will click it when you're running it. And how do I do this? How do I explain this? How do I explain this? All right, let's just, how much time do you have?
It depends on you. Actually, you're the one who will dictate the time we have.
All right, let's do something for like 30 minutes. I hope people know they're almost sleeping. So I'll showcase something small. I think I have one installed on this box. I installed one a while ago, yesterday. I was thinking I'm going to do a loader today with parking capabilities. So by default, let's go and try and see whether we can do Maldocking in a little bit to actually just showcase it. So auto open, create. And you still, obviously, you have to have learned how to use VBA. So by default, obviously, it's going to be sub open, and then this is where you're going to specify maybe your payload. So your payloads may be dim payload as a string. I don't know if I'm doing the right way, but anyway, you'll see it later on as a string. This is supposed to be capital. These are not supposed to be comment, supposed to be executions. So comment by default, they are usually like this, or they can be ran for those people who have done VBA. Yeah, I've taken a lot of time to actually understand the coding. So payload, this is where you're going to specify your payload. So maybe your payload is going to be using maybe satutil. I don't know if you can hear me, or you can. I'm sharing. Am I sharing?
Yes, you are.
You can hear me. Okay. So I know MSI and other guys are going to obviously catch this. So you want to confuse them by writing your own obfuscator so that they don't see that when they actually run it. So what you want to do is that you want to make a small something that if you call it, it gives you a jumbled information about satutil, and it will execute satutil. So how do you do that? You can always make a simple executable for that. So what I'm going to do is that I'm going to make, I don't know if you have enough time. I'm also really feeling exhausted. I need to go and relax for today. So if you have time, if you have enough, you're going to do that. So let's say, we're going to call it payload and code. With your own levels of messing around with it. So I don't know if, what time is it? Jesus. Okay.
Let's say 26. I think let's do this.
So let me just explain, then we close. I don't have to write the whole code.
Yes.
You write the whole code next time.
That's okay.
Yeah, so encode it. So, but therefore, what you want to do is obviously you want to include the files, the headers that we talked about. So windows.h. And the other thing is obviously because you're going to actually be able to write the file. So where am I? All right, like that. So I'm just going to write in form of comments. So instead of writing the whole code. So we want to make sure we have arguments that are going to actually specify how you're going to execute the file so that you can actually be able to call a certain file, to call a certain executable on target. So the file is obviously going to be this encoder. So the arguments are going to be argument 1, argument 2, maybe argument 3, depending on how you're going to actually call it. So you're going to have some math calculation, maybe like you specify like a little bit of 10 times term. Then you specify sat util .exe. So the output should look a little bit mangled. It should look like something like this. And then what you do is that you take that mangled kind of encoded string and you put it on your Word. Here's my macro. Word. And by default, MSI will not be able to see what the hell is happening here until when the sat.util file has been dropped. So if it is knowing something which is dangerous, it's going to, like at that moment, it's going to wipe it. So, but that's one of the methods actually people do. The other methods people do, where you actually write another payload here. This payload or this information actually helps you to connect to another file which is already remote, which is downloaded on this wall and then executes. I've seen other methodologies that other people are using, but for me, I usually advise people when you're running an operation which is delicate, don't use maldoc because it's already a known GTP. Yeah, I think that explains it for the MSI people.
We need a separate class for that. And I hope you'll create time for that. So Jones. Jones, are you there? Since Jones is not, might be having issues, would you mind if you end the session and end the class and at least have the final word? Chucks.
All right, guys. Thank you for joining me today. Let's go and relax for the weekend. Make sure you study every morning, and let's make a better team in RTO and CNO and different organizations and countries as we go on. Because the more we have peace in our nations, the more our kids are going to enjoy their lives as they grow up. Thank you so much, and see you next time.